Let's now take a look at division of algebraic expressions. There's a number of symbols that can be used for division. X divided by y can be shown this way, or this way. The quotient, which is the answer of the division, is expressed as a dividend over the divisor. So x over y. X would be called the dividend and y would be called the divisor. But you can also call x the numerator and y the denominator. These terms are equivalent. The one thing you should never do is divide by 0. This will give you an invalid result. If we look at this expression here, we have to make sure that x is not equal to 2. If x is equal to 2, we have division by 0, which is going to give us an illegal operation. So we have to avoid that. Now the rule of sign says that if we divide two numbers of the same sign, such as positive a divided by b, or minus a divided by minus b, our answer is going to be positive. If we divide numbers of unlike signs, such as positive a divided by negative b, or negative a divided by positive b, then our result is going to be negative. This is a summary of the rules of signs for division. If we want a positive result, we have to divide a positive by a positive, a negative by a negative, or have the negative of a negative over a positive, or the negative of a positive over a negative. To get a negative result, we have to have a positive divided by a negative divided by a positive, or the negative of a negative over a negative. Let's take a look at this expression. We can rewrite this as minus 1 times ax squared over minus 1 times y. And we can divide out the minus 1's, and we're left with ax squared over y. So these negative signs here can be thought of as negative 1 times that. Let's take a look at dividing a monomial such as 6ax by 3a. In this case, we can divide 6 by 3 and end up with 2. We can divide out the a's and we just end up with 2x. At this point, we should be fairly familiar with this kind of division. Y to the 5 over y to the 3 is y to the 2. If we look at this, we have 15 divided by 3, which gives us our 5. And then we got x to the 6 over x to the 4, which is going to give us x squared. So we have 5x squared. In this case, we have 8.35 divided by 3.72, which gives us this number to the same number of significant digits. Then we have y to the 5th over y to the 1, which is y to the 4. In this example, we have 18 divided by 3, which is going to give us 6. We have x to the 5th divided by x squared, which is x to the 3. We have y to the 2 over y to the 1, which is just y. And we have z to the 4th over z to the 3, which is just z. Sometimes we're going to get an answer that has a negative exponent. However, we want to always express these as positive exponents. So this can be rewritten as 6 over x to the 3 by doing the reciprocal. Let's take a look at this expression and see how we can expand it out. First of all, we have 3 divided by 9, so that's going to be something over 3. We have x squared over x, which is x to the 2 minus 1, which is just x. We have y over y to the 4th, which is going to be y to the minus 3. And we have z to the 5th over z to the 2, which is z to the 3. Put this in a proper form, we can just say x z cubed over 3y cubed. And that's what we have here as our final answer. Let's take a look at example 67. And I think right away you can see that we can divide 21 by 7 and end up with 3. Next thing we have to look at is the x term. We have x squared over x to the minus 4. So that should give us x to the 2 subtract negative 4, which is 3x to the 6. Next, we can look at the y term. We've got y to the negative 3 over y squared. So that's going to be y to the negative 5. And finally, we have our z term, and this is z to the minus 1 over z to the negative 3, which is going to be z to the minus 1 subtract negative 3, which is going to give us z squared. Now, the only thing left to do is to rewrite this so it is a positive exponent. And that should be 3x to the 6 z squared over y to the 5th, which is exactly what we have here. Let's take a look at dividing a multinomial by a monomial. And let's take a look at dividing this number by 3x. When we do that, we put all of this over 3x. But since 3x is a common denominator, we can put each of these terms over 3x in this fashion here. So we can take this term here and write it as 1 over 3x times all of this. If we look here, this term is 9x squared over 3x, so we can divide the 9 and the 3, and we get our answer of 3 here. We can also divide x squared by x and get our x term. We can take 3x divided by 3x and generate our 1 term. And finally, we can take minus 2 over 3x and just add it to the end, and this then becomes our final solution here. Now, the most important thing that you have to remember is you have to divide every term by the denominator. So x squared over x, that gives us x. 2x over x gives us 2. But 3 should be 3 over x. And this is a common mistake that you can make. Now we've taken this complete term here and rewritten it over 15ab. So we can divide the 3 by the 15 and get 5 on the bottom. We can divide out the a's, divide out the b's, so we end up with 1 over 5 for this term here. The next term we have 2 over 15, so there's our 15, there's our 2. And we have a squared over a, so that gives us our a, and the b's cancel out. So that gives us our term 2a over 15. The third term is 5 over 15, which is going to be minus 1/3. Then the a's divide out, and b squared over b goes once. So that ends up giving us a term of minus b over 3 for here. Our final term is 3 over 15 again, which is a number over 5. Then we have a squared over a, which gives us our a. And we have b squared over b, which gives us our b, to make our final term ab over 5. So we've gone from this to this by simply writing down the common denominator under each term and dividing out what we need to. On number b here, we can write out and put an intermediate step of 6x squared y over minus 2xy minus 8x y squared over minus 2xy, and finally minus 2x to the fourth y to the fourth all over minus 2xy. When we do that, we can cancel 6 over 2 to give us minus 3 here, and I think you can see that the y's go out and we're left with x squared over x to give us a total answer here of 3x. On this one, we have minus 8 over minus 2, which is going to give us 4. We have x over x cancels out, and we have y squared over y, so that's going to give us a total of 4y. On our last term here, we have minus 2 over minus 2, and we have x4 over x, which will give us our x3. We have y4 over y, which is going to give us our y3, and this again will then generate our final answer. Now after a while, you should be able to be a little better at this. So we're going to take 8.26 divided by 2.82 and make sure we've got 3 significant digits of accuracy. Now we've got x cubed here over x, so that will give us our x squared. The next term is going to be this number here, and make sure it's minus, and divided by here, which is going to give us our 2.21. And we have x squared over x, so that's going to be minus 2.21x. Now we're going to divide 7.37 by 2.82 to generate this number here. And I think you can see these x's are going to cancel, so this becomes our final answer here. Now suppose we're asked to divide x squared plus 4x minus 2 by 1 plus x. First thing we have to do is take that first term and write it with the highest exponent to the left. So we're going to write 4x to the fourth. Now we also have to fill in terms that aren't there, such as x cubed. There are 0 x cubes. But there is an x squared. There's no x's. But there's a minus 2. So we have to expand it out so we have all the terms from x to the fourth down to the single digit minus 2. And then what we have to do is we have to divide this all by this number here. but we have to change this around. So this is going to be x plus 1. What we have to do is figure out x is going to go into this so many times. So what we have to do is figure out a number like 4x cubed. So when we multiply this 4x cubed by this, it's going to give us 4x to the 4th. So we can eliminate that term. So we multiplied 4x cubed by x to get 4x to the 4th, but now we have to multiply 4x cubed by plus 1, and we have to write in plus 4x cubed. Now we can see when we do the subtraction, we're going to lose the 4x to the 4th, but we have 0 minus 4, which is going to give us minus 4x cubed. Now we should write down the rest of what we have up here, so we're going to write down plus x squared plus 0x minus 2. Now how do we get rid of the minus 4x? Is by multiplying x plus 1 by minus 4x squared. Minus 4x squared times x is going to give us minus 4x cubed. Then minus 4x squared times 1 is going to give us minus 4x squared. And then when we subtract these, this goes out and we're left with 1 subtract minus 4, which is going to be 5x squared plus 0x minus 2. Now what we have to do at this point is come up with something that's going to get rid of the 5x squared. So we're going to add plus 5x. 5x times x is 5x squared plus 5x. So what this is going to give us is 0 subtract 5 is minus 5x minus 2. What we have to put in next is minus 5 is minus 5x minus 5. Now if we do this, minus 2 subtract minus 5 is going to give us 3. So the answer for this problem is going to be 4x cubed minus 4x squared plus 5x minus 5 plus 3 over x plus 1, because 3 is a remainder, and that is something that would not go in evenly. So this is our final answer here. Let's look at dividing this polynomial by this polynomial. Now as before, what we did was we ordered all of these in the proper order: x to the 4th, x to the cube, x squared, x, and single digits. We have x to the 4th minus 5x cubed plus 9x squared and so on. So we want to have something that if we multiply by x squared, we're going to get x to the 4th. Multiplying by x squared will do it. So this is x squared times x squared, which is going to give us x to the 4th. We've got x squared times minus 3x is going to give us minus 3x cubed. We've got x squared times 2, which is going to give us 2x squared. So that's our first term. Now when we do the subtraction, we got minus 5 subtract negative 3, which is going to give us minus 2x cubed. We have 9 subtract 2, which is 7x squared. And then we still have these terms here that we're going to write down here. So the next thing we have to do is figure out how to eliminate the minus 2x cubed. And by doing that, we can just put in a minus 2x here, and we'll see how that works. Minus 2x here times this number here is going to give us minus 2x cubed. Minus 2 times minus 3x is positive 6x squared. Minus 2x times 2 is minus 4x. And again, we're going to do the subtraction. So the subtraction is going to be 7 minus 6, which is going to give us x squared. Minus 7 minus minus 4 is minus 3x. And so we write that down. We still have to carry the 2 here. So we're left with x squared minus 3x plus 2. And I think you can see that that goes in 1 with 0 remainder. So we can see when we do that division, our answer is going to be x squared minus 2x plus 1 plus 0 over x squared minus 3x plus 2, which is really the same as x squared minus 2x plus 1, because there is no remainder. Otherwise, we would put our remainder number here, and that would be our final term.